There's only two forces that are in this picture, since we don't see what happens at the wall at B. We'll have minus AX plus 15 times x minus 120 squared. Again, half the intensity times x minus the offset squared. As we said at the top, there are three reactions here: the force, vertical force at A, vertical force at B, and a moment at B. What are the three boundary conditions then that we have for this problem?
V at 0 is equal to 0, and V at 240.
All right, so we'll start with the deflections like we've been seeing. At A, or at x equals 0, we know the deflection has to be 0, so V of 0 is 0. At the wall, it's also true that it can't go up or down at the wall, so it's going to be 0 at 240 inches. Yeah. Right, and in this case, the slope at the wall has to be 0. So that point attached to the wall can't move up or down, and it can't rotate. So again, we have to base on the boundary conditions are based on the types of reactions we have. A force at A, a force at B, and a moment at B. That moment at B says that the slope at 240 is also 0. So V of 0 is 0, V of 240 is 0, and V prime of 240 is 0. We haven't seen this before where we had that moment, but in our boundary conditions we have to use sometimes the deflection equation, and in this case that slope equation is going to come into play since we know the slope at 240 is going to be 0. Because the deflection at 0 is 0, that means that C2 drops out, or C2 becomes 0. Our deflection at 240 inches, we want to use the deflection equation. Which will have A and C1 in it. And then that new step, or that different step that we've seen before, V prime of 240 is 0. I want to use now this equation and set it equal to 0 when x is 240. In that case, I'll have A over 2 times 240 squared minus 5 times 120 to the fourth, 120 to the third, plus C1. Between equation 2 and 3, I have A and C1, and I have A and C1. So I actually can solve for A and C1 at this point. I don't have to wait until I have my equilibrium equation to get those numbers. So I can find that A is 394 pounds. I should mark here that we're working in pounds and inches. C1, I get negative 2.7 times 10 to the 6. B is 3,210 pounds up. And if you find the moment at B, you should get 121,000 pound inches.